Hello, I'll be rolling a six-sided dice 100 times to record the outcome of each roll, and then performing a chi-squared goodness of fit test to determine if the die is fair. Let's get started. 1, 4, 3, 4, 2, 2, 3, 6, 2, 6, 1, 5, 6, 4, 1, 1, 3, 3, 6, 1, 2, 1, 2, 6, 5, 5, 2, 3, 2, 4, I'll redo that one. It fell off the table. 5, 1, 2, 3, 2, 4, 1, 4, 2, 5, 3, 5, 2, 5, 1, 1, 3, 4, 2, 3, 4, 4, 3, 3, 5, 2, 1, 6, 2, 6, 5, 1, 1, 4, 6, 4, 6, 3, 1, 6, 5, 4, 5. 4. 4. 2. 5. 6. 5. 4. 6. 1. 6. 1. 2. 4. 6. 1. 5. 1. 1. 5. 1. 4. 3. 5. 4. 4. 5. Okay, that was the last roll. Let me just get on the numbers real quick. Okay. Alrighty, now that we've finished our rolling, we have our total number of rolls is equal to 100. The number of times we rolled a 1 was 21 times. We rolled 2 16 times. We rolled 3 13 times. Rolled 4 19 times. 5 17 times. And 6 14 times. The expected value for each possible roll is going to be 1/6, which is the chance of rolling an individual number in one specific roll, multiplied times our total amount of rolls, 100. It's going to be equal to 16.66 repeating, or approximately 16.67. Our null hypothesis is that the die is fair each face has an equal probability of 1/6. Our alternative hypothesis is the die is not fair. Okay. So we're going to be using the chi-squared goodness of fit test. And the assumptions we need to have before we can do this are each expected frequency, that's weird looking, frequency should be greater than or equal to 5, which is, ours was 16.67, so that's good, it's greater than 5. We have the observations should be independent. We're good there because one of our roles does not impact the results of any of the other roles, so they're independent. And then lastly, the categories should be mutually exclusive. And this is correct because if you roll a 1, for example, that roll cannot also be equal to a 2, 3, 4, 5, or 6, and that goes for any of the other results as well. All right, now that we've checked off those 3 conditions, we can start by finding our test statistic. We're just going to take each one of our results and subtract them from their expected value, square that, and divide it by the expected value again, and then take the sum of that for each possible 1 through 6. All right, once we sum those all up, we get 2.719. Now the next thing we're going to have to find is our critical value. And the critical value for A equals 0.05. And then we need the degrees of freedom, which we get our total amount of different possible outcomes is 6. And then we have to subtract 1 from that. It's going to be equal to 5 degrees of freedom. And once we look in the chart, we see that's equal to 11.070. And our value 2.719, our test statistic is less than our critical value of 11.070. And so what this means is that fail to reject the null hypothesis of the die is fair. My bad. And insufficient evidence to support NA die is not fair at A equals 0.05 significance level. All right, and that's how you're gonna do the chi-squared goodness of fit test for evaluating the rules of a 6-sided dice. Thank you so much.